the center mass. Basically, center of mass is the position of the average position of all masses in an object, usually located at the center of the object. For example, in this water bottle, the center of mass would be where I can balance it from the middle. And the center of mass is where we can balance an object as shown by balancing this water bottle. And the concept of the center of mass can be applied to either an object or an overall system. Center of mass is also the position where all the vectors in the system sums up to zero.
Going back to geometry, to find the centroid, which is the center of mass for in the geometric way, we have to find the median of the equation. Since our line is a curved line, we can just imagine it as a straight line, and then we can find the midpoint by taking the x of both point and then divide by 2, and taking the y of both point and divide by 2. And since this is our boundary point, so we don't really have to calculate it that much. So to find the line, we need to use our slope-intercept formula, which is y equals mx plus b. And basically what we do is we take this 2 point and this 2 point, and we find the slope of them first. And since we know that one of our point is pi 0, it basically is x equals to pi. So we can just plug in pi into x, and we'll get y equals 4 over 3 for this 2 point. And then we can do the same thing to test out if we actually calculate correct or not for this 2 point. And then since we all get y equals 4 over 3, we know that pi comma y 4 over 3 is our coordinate for G.
So we're looking at the algebra way right now. We find the 3 boundary points. It's 0, 0, pi 4, and then 2 pi 0. So we take this point, the coordinate of the point, and we find the average. We find the average of them for the x coordinate and the y coordinate. So the process is we add them up and divide by 3, and so we got pi for the x coordinate. So for the y coordinate, we also add them up and divide by 3. So we get 4 over 3. So our A is pi 4 over 3.
So now we're looking at how to derive the calculus equation from algebra equation. So we first have to know that mass equals density times area, and area is the integral. So to derive the equation for x, we have to break out the summation. So m becomes p times integral, and then we're left with the x. So we're just putting the x inside of the integral. And the bottom part becomes p times area, and then we write area as integral. And p cancel out on the bottom and top and bottom. So the denominator becomes just a, so we can rewrite it a little bit as 1 over a integral a to bx fx dx. And to derive the equation for y, we do the same thing, but there's a slightly different, because y, we're looking at a rectangular slide region, so the center of mass is basically half of the height, which is a half fx. And then to write it more neatly, we can get 1 over a integral a to b, a half fx squared dx. So now we are finding the center of mass in a calculus way. We are just plugging equations and numbers. But first we have to find what is area, and area is integral from 0 to 2 pi for sine x over 2 dx, which due to my calculation is equal to 16. And we know that our equation is for sine x over 2, which we can plug in for fx. and our interval is just from 0 to 2 pi. So to do calculation, we can know that our coordinate is pi and pi over 2.
So now we're finding the center of mass in a physics way. So when we pull in the object, so there will be a tension force pulling up. So but it's still like stationary, which means there's no net force. So which means the force downwards cancel the upward force out. So which means, but there's only one downward force, which is gravity. So to cancel the force out, they have to be in opposite direction and in the same line, which means the upward force, tension force, is in the same line with the downward force and gravity. So also we know the gravity is, theoretically, the center of mass is where all the gravity applies on. So to find the gravity, where the gravity applies on, we can find the center of mass. So it should be in the same line here. So if we put in another point, it will also be in the same line. So if we draw these two lines, so the center of mass will be in the intersection of the two lines.
So after we made the board, and then when we tried to balance the pencil at the point A and G, the cardboard tilted to the left. And when we tried to balance it on the C-spot, however, the cardboard tilted toward me, and only at point P, which is I like the exactly middle of the board, it balanced perfectly with the stick.
So we assume that the calculus way is the most accurate one, and since we find the point A and point G is the same point, so and the percentage error is 15.34, and for the point P we find the percentage error is 14.58, which means the point P is more accurate. And through the experiment, we find the point P balanced the best, although calculus is like worse than the point P. And to make it more accurate for the algebra one, we can set the more boundary point for the algebra one. Also for the geometry one, we have more than 3 boundary points. It is possible to find the centroid because there's only one centroid. So if we have the multiple lines, but they still intersect at that one point. Okay. So the physics one is more accurate because it's pretty more like practical. So since there's many like source of error because like we punch a hole on it and the shape is not really perfect, and the distribution of mass is not really like pretty even, and also we also draw the grid, and which means there's no really accurate stuff, and we can't really find the pi where the pi is. And so that's why when we find the coordinate, it's not really exactly at that point. So but when we find the P, the physics one, we don't find the coordinate but the actual point on the object, so which will be more accurate.